Next we need the artist table and the film artist table. In the artist table we're going to store an ID and first name and last name, similarly with the customers table. As I worked with the database a little more, I decided that I would combine the first name and last name to a single name field. This will allow us to simplify searching on a particular artist's name. We should realize that this is a denormalization because we've broken the principle of atomicity of data. However, as I mentioned in an earlier chapter, there are certain instances where denormalization can, if effectively used, be very helpful in our database design. This is one of those instances. So we're going to change the first name and last name to just a single name column. In Film Artist, the bridging table, we're going to store the film, which will relate to the ID column of the films table. We're also going to store the artist, which will relate to the ID column of the artist table. We're also going to have the particular job that the artist has done on the film. This will be one of three choices: actor, director and writer. As you can see, here are the two sets of SQL statements to create those two tables. The film artist table, the bridging table, has a primary key, and that is the film combined with the artist columns. So essentially we have a unique identifier in terms of the film and artist combination. We've also used an enumerated column type for the job done to ensure that we have strict control over the kind of jobs that film artists can be doing within our system. So there's the artist table and the film artist table completed. Now we're going to look at another central entity within the entity relationship diagram, and that's the copy. I'm going to translate this into the copies table. We're going to once again use an auto-incrementing primary key. That's the ID field. We're going to have a film column, and that's going to relate to the ID column of the films table. So that creates the relationship there. We're going to have a rendered to column, and that allows us to at any time be able to see who the particular copy of the film has been rendered out to. If it hasn't been rendered out at the moment, in other words it's on the shelf, then this field will be null. We'll also include a rented by column so that we can keep track of which employee is renting to which customer and which film they're renting. We also need a date due back. Once again, all these three fields, the three last fields, will be null if the copy is sitting on the shelf. We also need format. This allows us to differentiate between VHS and DVD. This is what it looks like translated into an SQL statement. That's the copies table. Let's take a look at our employee entity, the final one. And here's the employees. Here's our ID column, again a primary key. Some personal information about the employees. And a title column. This title indicates whether they are a boss or an employee. And I've chosen to call the employees droids, no particular reason, other than the fact that all employee term is too generic because even the manager is an employee within the shop. So in order to avoid any confusion, I've added the slightly facetious moniker droid to all the sales assistants. Here is the table in SQL form. As you can see, there's an enumerated field there, the title column, which allows us to select between manager and droid. So these are our tables that have been created from our entity relationship diagram. And in our next movie, we're going to start looking at the way in which this database design is used within our application.